Hello, linear algebra student. This video is for chapter 1.8, part 3. We continue with proving a particular transformation being a linear transformation. So we define it this way. We define something as like x1, x2, x3. The output is x1 and x3. The x2 becomes 0. So if I multiply so we prove part 1, which is t of u1 plus t of x plus t of y equal to t of x plus y. And then now we're going to prove if I have a constant and I multiply to x2, x3, and then I do the transformation, would it be the same as I multiply afterward? So this is y1, y2, y3. It's very messy. I'm going to erase this and do it again here. So the notation is kind of messy. So this is the input was x1, x2, x3. And then I'm going to see if I can do it first and then multiply the c later. Are they the same? x1, x2, x3. Right? Is it the same? Doesn't involve y. So now if I do this, so that means t of cx1, cx2, cx3, right? So if I go this way, and then this will become what? Will become cx1, 0, cx3. And for this will become c times just x1, 0, x3. And I multiply in, it would equal to cx1, 0, cx3. And they are equal. So we don't know if they're equal. So this is equal. So it satisfies both. That means T is a linear transformation. It's a transformation okay, but it is also a linear transformation. So whenever you are to prove something as a linear transformation, you have to prove these things, these two requirements. The second part of after we talk about linear transformation, we would talk about how we can use these to use transformation to look at how to reflect or how to do real geometric transformation in R2. So for example, if I do a transformation, t of x could be any vector, and I multiply this vector by r. In this case, x is in R2, it's just x and y, x1 and x2. I multiply by r. So this becomes, if I have a vector and I just make it longer or make it smaller, right? So this is so if I have, say, for example, like this one, I have a vector 1, 2, and r is 4. Then t of 1, 2 become just multiply this 4 times 1, 2, right? Because t of x is r of x, so it's called a dilation, so it's 4x. So everything is longer. You can plot it this way. So this is a dilation. Also, I can have another transformation. So the transformation goes like this. It would rotate a point or rotate a vector 90-degree counterclockwise by, if I multiply by 0, -1, 1, 0. What happened is, so if I just try to multiply it, what would happen? So this would become row multiply column will be -x2, right? Row multiply column, add together, that will be x1. So meaning, originally I would have x1, x2 here. This is x2, this is x1, and this is x2. Now, so this is the original vector. Now, where is x2? x2 is negative. So whatever that I have, this should be smaller, right? But in the negative side, the y become the x, and then it would go up the x number. So it'll be here. So this is -x2, x1. Do you see that it is So your vector now become here, and this is 90 degrees, so it's a rotation counterclockwise by 90 degree. After you multiply it, x1, x2 become -2 x1. Okay. So we're going to study more of these. So I have a matrix. I have two vector, -5, 2 and -2, 4. And I want to find out what happened. 5, 2. Should it be 5, 2? I don't know. Yeah, I think I'm going to just do 5, 2 because otherwise they run into each other. So let's say plus 5, 2. And we want to do a matrix transformation by multiplying this to both of them. And we want to see what happened. Okay, so um, A of 5, 2 become what? Become 0, 0, 0, 1 times 5, 2. The row times the column become, or 0, right? 0 times anything is 0. And then the second one will be this row times this column. We just have 2, right? We just have 2. So you reduce whatever that you have into 2. And then if I do a -2, 4, what happened? So that would be 0, 0, 0, 1, -2, 4. When I multiply this by this, it's all 0. When I multiply the second row by this, it is only 4. So you basically just take the second one. So let's see. Originally, the vector was 2, 5, right? It's over here. 2, 5. What does it change? It changed into 0. No, it's 5, 2. This is wrong. Not 2, 5. But 5, 2. 5, 2. So it's a vector is like this. And then what is the image? The image becomes 0, 2. So that means don't go left and right, but here. So this is the answer. So basically you map it, so you project your vector onto the x2 axis, right? So it's a projection. Projection to the x2 axis. Kind of like the shadows of this vector onto the x2 axis. So this is the geometric description. What about if I multiply a equal to 0, 1, 1, 0? Let's try for 5, 2, and 2, 4. So after you do a few of them, 5, 2, so that would equal to 0, 1, 1, 0 times 5 times 2. What would it become? It would become this times this plus this times 2 is become 2. And for the second row, it will be 1 times 5 plus 0 times 2 is become 5. So basically switch your x and y, right? So let's see if it's the same for -2, 4. So -2, 4, I would do 0, 1, 1, 0. But -2, 4, -2. So multiply 0 times 2 plus 1 times 4, that's 4. 1 times 2 plus 0 times 4, that's 2. Again, oh, is it negative? Negative, right? This is a negative. So it's 4, -2, your x and y switch. So let's draw what it is. So I'm going to just draw one. Okay, so 2, 5 was, no, 5, 2 was here, right? Was the original one. But the new one become 2, 5 here. What has changed? X become y, y become x, right? So it is a reflection in the x equal to y axis. If I have -2, 4, it was this one. Now become 4, -2. 4, and then -2. -2, -2, 4, right? 4, -2. Let's check if it is the same. Yeah. Hmm. Okay, so -2, 4, -2, 4, I draw wrong. It'll be here, right? -2 and then 4 should be here. And then 4, -2 was 4, and then -2 would be here, right? This is wrong. I draw it wrong also. So the first one that I drew was -2, -4, which is not what I want. I want -4. So you can see that they are reflection over the x equal to y axis. So you interpret it by saying multiplying 0, 1, 1, 0 is a reflection of x over the x equal to y line. Right, so use this as the axis of symmetry, you reflect it, and this one reflect. If you draw more, you can see how it goes. So this is 1.8. Basically, you need to know how if you multiply something to a matrix, there's some geometric meaning, and we'll talk about more of this in 1.9.